Okay, so welcome to SoundtrackAH or SoundtrackAH. So today I'm going to demonstrate this music identification system that I built using Palantir Foundry, which takes video input and automatically identifies background music using comprehensive metadata from songs. So the key challenge of this project was building it entirely offline since Foundry has no internet access. I'll get into more of that later. So starting with data collection, I used both the Spotify API and Deezer API to generate curated playlists of songs that I thought were popular enough to be identified from videos. And what Deezer did was generate 30-second previews of these songs using the song names that I got from the Spotify API. So I built a local script to run these to collect over 1,000 song previews and their metadata, and then uploaded those to my Foundry datasets. And the reason I did this was because Foundry doesn't have outbound internet access, so I was unable to make API calls to the respective API services. So the second challenge that I faced due to Foundry's no internet access was integrating PyTorch's VGG-ish model to generate audio embeddings. So normally VGG-ish automatically downloads weights and PCA parameters to generate audio embeddings, but this is impossible in an offline environment such as Foundry. So my solution was to create my own type definition for VGG-ish, and instead of using uh, the URLs that the model uses to download its weights and PCA parameters, I downloaded those packages locally into Foundry and then used those in my type definition for the model to access. And then I implemented this into later files where I needed to use VGG-ish again. So using um, model repositories on Foundry, I deployed my random forest classifier model with a custom adapter that wraps around this classifier. And this allowed for proper confidence scoring of inference data or test data. So what this script is doing is first I'm using the custom VGG-ish model that I used to generate the embeddings in the first place, and I'm generating embeddings on the test audio or inference audio. The classifier is then taking these generated embeddings and comparing it with the data it was trained on. And I did this in 30-second intervals to get the maximum confidence for the model. And this way it would be like the most accurate to what the input audio actually is. And in the end, we output a data set which contains the prediction essentially of what the model thinks the song is. And yeah, as you can see here, around the mark of the preview, 30-second preview, that the model is recognizing that the songs are the same. So yeah, obviously the sample size was a little small for the amount of songs that exist, but with enough training data, I believe this application will be very useful for media companies or content creators in the future and be able to identify songs that are used within videos.